Hello everybody and welcome to the stream. Today we are designing a monitor stand. Sorry, not a monitor stand. A headphone stand. For the headphones I am wearing right now. Um, I need a place to put these. I've always found that if I don't have a place to put a thing, my room's messy. I don't know. It's for everything that doesn't have a home, the more messy your life kind of becomes. So these headphones, I just kind of shove them wherever they fit, and that doesn't always work for me. And so I want to make a place to put them. Um, so for this stream, we're gonna hop over to Sketchbook. This is a free product from Autodesk. I've just started to get used to it, so hopefully I can get my ideas out pretty clearly. Um, and then we are going to move over to Fusion 360 where we will actually design it. And then we'll try and lead the stream as we print this beast, and hopefully it prints first shot and then it works first shot. So, to give some context around kind of initial inspirations, because I was thinking about this earlier, let's bring up the portfolio. Switch over to Chrome. Cool. So, I designed this guy, this little stand, um, some time ago. This is what it looks like. The phone fits right in there. And it's designed very much off of kind of 30, 60, 90 degree angles and parallel lines. So general ideas is that roughly, so let's see, so pulling this design up, we have like angles like this, and so this angle here might be 60. If we look at the side of the entire case, it basically looks like that. And so this is 60, this is 60, and then math says this should also be 60, which makes this angle here 120. So, a little geometry refresher. Any two angles, x and y, along a straight line and then a line off of that must equal 180. So our constraints are going to be kind of 60s, 120s, 30s, things like that. And then parallel lines. So like this bit right up here is parallel to this line here, parallel to this line here, and then this little bit here is parallel. So like if that came down, yeah. So that's kind of the inspiration. So we could call it like the 30, 60, 90, 120 headphone stand. So that's the first thought. I was debating whether I wanted it over the desk or under the desk. Or sorry, on the desk or like attached to the side of the desk. And I always found that this cord, as it runs kind of to the back of my computer, it's very long, it's very annoying, it's not wireless. Doesn't really work, and I don't want it on my desk, and I don't want to take up more space because I've been trying to do my best to kind of declutter my desk recently. So I've given thought to. Let's just delete that. We don't need that. We'll just leave a little note. Whoop. 30, 60, 90, 120. Cool. I had thought up a design kind of similar to the phone stand that would have just been kind of, if we're looking at a cross section, the headphones would kind of rest over this. This darker black line would be like a hook. And then headphone stand would just be like that, like kind of like a Z shape of sorts. Um, and then this height, be like a lot of plastic to do this. To like keep it on the desk. Kind of rambling a little bit here. If we go to look at headphone stands, Google, these two, yes, the two options are kind of like something that attaches the desk or something that goes on top of the desk. And I want it out of the way, so I had ideas for all these kind of fancy things, but I want it to hang off the side of the desk, I think, is what I've decided on. So if we look at, I'm going to get out my calipers, trusty calipers, and I want to measure some dimensions on my desk. So the thickness of my desk is 37 millimeters. So if we look at kind of, imagine if we sawed my desk in half like this, and then we looked in the side this way. So I'm just making sure that, yeah, that can actually be seen. And then we looked at like this, we would see that my desk, so we say this is the top right here, goes down, goes over, and then back up a little bit. There's basically two pieces of wood. Not so important, but there's a piece of wood here attached to another piece of wood here. And that just goes off to the rest of the table. So this is kind of, this area right here is kind of where we want to work. So if we're looking at that, I should give myself some room so I can take dimensions. Let me double check that. So 37.5 millimeters here. Oh, that's not how you draw a 3. 37.5. And then it's 38.5 millimeters back. And then this right here is 19. These are weirdly all halves. 19. Whoop. Oh, man. Oh, let's not do that. Let's also not do that. Okay, let's try this again. 19.5. Cool. Okay. So my thought, I don't even know if I can use that little 60, 30, 90 bit that I talked about. I think just going to end up having some plastic that, let's see if we can change colors on this. Since my plastic is red, perfect. I think it might be something that like wraps around like this. And then the most basic shape, it's probably going to be something like this. Maybe not that wide. That looks better. Cool. And then kind of have two options for hooks. I think, let's see, if that is 38.5 millimeters, so we'll say this is the desk. And then we need kind of the headphones. So the headphone cross section, called the HP for headphones. I'm gonna have to take my headphones off for a second, so I'm gonna mute myself so I don't make too much noise, and I'll take those dimensions, and then I'll be back. All right, so what we have here is, okay, so interesting. So the thickness of the desk going back, or the depth of it, is actually the same as the headphones. So if there's a hook, was like, well, change it back to red. If the hook was like right here, picked red. There we go. Cool. So the hook was like right here. This depth from right here to right there where the headphones would sit would be roughly 38.5 plus the thickness of the plastic right here. And if we're going, let's see, the old phone stand has a thickness of 4 millimeters, so we probably want 4 millimeter thickness. Would mean that 38.5 plus 4 would give this whole inner area 42.5. Which means if we added a little lip here, maybe make a fancy lip, the headphones would just fit kind of right in there. And thinking if this is enough to just pop this into Fusion 360. For anyone joining chat, if you have any questions, feel free to throw them in chat. Be glad to answer. I wonder if there's anything. Let's go with a different color. Let's go with blue. If there's anything to do with this section, because I'd rather not have this sticking onto my desk. But there's like nothing underneath the desk to hold on to, unless I ran screws into my desk. And that's a possibility. So I ran screws into my desk. So let's undo this blue line. Let's sketch our desk again, cross section. If we ran a piece right here, this blue mark was a screw. Could run a screw right in here and up into the wood. Which just feels more universal. I don't know how strong these screws have to be. Like 4 millimeters here seems pretty strong. And if we had, let me take my headphones off real quick. That's not bad. One random quick thing I'm just remembering. I want to make the gap here be at least greater than 17 millimeters. And same over here. Greater than equal to, oh, it's not greater than. Greater than equal to 17 millimeters. Cool. I'm trying to think if I have any screws that could be used for this. I'm going to peek on my shelf real quick. I will be right back. Okay. I'm actually going to mute myself. This might be. Oh, sorry, I muted myself. Basically, my screws are really big. They're 1.25 inches. Oh, yeah. Sorry about that, Hellcat. Arbella. Yeah, so I was saying that the screws I have are 31.75 millimeters, and they would go through my desk. So I had these guys, which I think I could actually use to build my desk, if I recall correctly. Yeah, I'm pretty sure these are what I use to at least connect kind of this bit of wood down here to this bit of wood up here. So they don't pop through the top so long as there's two pieces of wood stacked on top of each other, but underneath here going to have an issue. So yeah, I'm going to peek if I have anything else in here. Kind of wish I was still a member of a makerspace because I used to have access to a lot more raw materials, and now that I'm just kind of in my bedroom, Gotta make do with what I got. Okay, these could work. These are from bits I have from making picture frames. Your makerspace is closed still. Yeah, that's a bummer. Mine started going through some changes, and I decided it was time to take a break, which is kind of ironic that I took a break just as everything went to crap anyway. So wouldn't be able to go there if I was a member anyway. How are you keeping yourself occupied in these times? I've managed to hold myself up in my room and find tons of side projects to to try and keep busy with. Sharpening my programming skills. Nice. I like it. Yeah, I got some. If you look down below, I've tried to create a little wish list of things to work on. And so I'm going to try and start learning some new programming stuff. My day job is programming, but would like to expand my skills out into C++. I learned today that you can do Python with Fusion 360, and so that seems like kind of mind-blowing, but would be something fun to work on if you could like figure out how to write code to make 3D models. Okay, so it looks like I have two options for screws. Are you saying what to the Python and Fusion 360 bit? Yeah, so I found I didn't really watch it because my brain was about fried when I found it, but yeah, it looks like you can. It looks like a lot, but it could be fun. And you could also do it with JavaScript. So I found this video getting started with Fusion 360 API that at some point I'll watch. Also, you might be interested in. Have you ever heard of the program OpenSCAD? You can. It's basically you write code. To generate your CAD files instead of like actually like clicking and dragging and stuff. So a coworker showed me this the other day, and it's free, so that could be fun to check out as well. I'm just staring at the screws that are in front of me, and I don't know which one to pick. I think I'm gonna go with the smaller ones. So these guys are. They'll go into the wood about 9 millimeters. Ooh. I keep clicking things and I don't know. There we go. Okay. So if I can draw a straight line, I can't not draw a straight line. There we go. 9 millimeters. So we don't need all of that. Oh, that looks terrible. Okay, there we go. Just paint this solid red. Okay, not gonna do that. So if, let's see, let's do green. We'll say, let's bring this area and we'll bring it out. And this area will look like, so I'm trying to only draw the bits that are in the circle and make them larger so I can actually see what I'm looking at. Okay, so right here, it'll go up like this, and then that'll be where the screw goes through. The screw head is 2.5 millimeters thick. So we'll make this 2.5 millimeters. And then this is, say, like 8 millimeters. And then this smaller hole for the threads to pass through will be about 3.5 millimeters. Cool. And we'll probably want like 3 screws across. I think so. Let's leave it as to do. Let's put it up here. And we'll call it like screw hole pattern. And my reasoning for putting that there is I can't tell if I want to put the screws in like triangle, like underneath up, or in like a straight line. So we'll do that in Fusion 360. Am I using a pen? Yeah, I have a little Wacom tablet that I purchased that I found it easier to do these kind of drawings with. I figured it'd be better for everyone to see. I used to draw notes in my notebook, and then I'd like just tell the camera, hey, I'm drawing on my notebook, and I don't think anyone could tell what I was doing. So the hope was to have something a little bit more easy to follow with. Is it useful for 3D sketches, or are they not necessary? By 3D sketches, do you mean like this kind of 3D sketch? Or do you mean like actually doing stuff in CAD? In CAD. I haven't used it in CAD. I did see this thing the other day. There's no way I find this again because it was actually an advertisement. See if I can Google this or search this at all. Trace shapes for CAD. No, there's no way I find this. It was like a brand new company that was advertising. Oh wait, I found it. So I thought this was pretty cool. I don't know if this is quite what you asked, but at least this is like two-dimensional CAD. And so what he has is he has this pen on this giant board, and you can trace shapes, and they'll show up in CAD. So he does things like where you can just do really simple, where you just take the pen and you draw along the shape, and that'll trace that right in a CAD. You can do more advanced things where, like, if you click 3 times, you can make a circle. So kind of like this would be in the shape that you're tracing. Get like a 3-point circle, and you say the circle hits at least this point, and that point, and then you get a circle for those points. I did play around a little bit. Let's see. I wonder what it'd be like to draw in here. Oh, hey, I have not tried this before. Okay, that's not actually bad. I wonder if I'd like try to trace my. I'm gonna put my phone on my tablet. Let's see if I can tilt the camera down so y'all can see this. So, okay. Oh man, this is trying kind of hard to do with 2 hands. There we go. Okay. So now we're looking at my phone. Okay, not quite. Nope. Oh gosh. I bet there's some way to do it, but that was. Oh gosh. Yeah, I bet there's like. Let's see. Actually. Yeah, so this display is like a lot more expensive than the one I got. I think it's like $2,000 or something. It's like basically a computer. Um, I don't know. I feel like this would be awful. Yeah, he's not really modeling anything. He's just looking at it. It is an interesting thought, though. Okay. See, he also went with the one with the screen. I guess it looks like it's possible. I feel like I would still prefer a mouse. Oh, clicking around all of the things. Okay. Let's sketch this thing. I feel like we've done enough looking at things. How? Okay. Okay, so I think this is the design that I want to try first. So There we go. Okay. So I think we're going to do a side sketch. So we're going to start here and we're going to sketch. What have I done? Oh, I'm sketching on the wrong plane. Okay, let's delete that sketch. Let's try that again. Okay, so this should be this plane we want to sketch on. Cool. So I'm going to choose this point right here to be our origin. And that's, we don't know how far back we need to go with that. And we said it's going to go down 4 millimeters. Actually, I learned a thing the other day that you can create parameters. And so I want to add a parameter called thickness. Just call it T. And make it 4 millimeters. Then, so instead of doing this, we can just put T, and that will also be equal to 4 millimeters. So I can change this if I want to change the thickness of my print. All right. So this will go back over to 40 minus T. And then we'll go down some amount, go at 45 degrees, or relative to that position, it's going to be 45 degrees plus 90, so 135. Some distance across, some distance up at 45, probably about the same amount. And then flatten back down. Okay, whoops. So we're going to need to drag this line back so that this point intersects here. Hit D to dimension. We're going to make this thickness T. Make this T. And make this T. Cool. And then we said that the thickness of the bit underneath is 38 millimeters, which means from here to this point it's going to be 38. Oh, interesting. Okay. Oh, it didn't maintain the angles that I had put. That's a bummer. Okay. 45. So once I start adding dimensions in, things start to kind of become constrained, like they don't move about as much. But there's still some movement, so I have to figure out, we need to dimension the length of this, which we know, which will be 19.5. Probably closer to 20. We'll round up a little bit. And I think we decided that this line and this line were actually equal, so we'll constrain them to be equal. Wait, this is supposed to be T. I don't know why I put 5. And let's kind of make this a little more legible. Cool. So last but not least, we need to define the length of this inner bit where the headphones will rest. What did I say? The headphones are thickness of 39. I'm going to take them off real quick. totally eyeballing this, but I'm just going to say this is 28. Yeah. Just moving this dimension out so it's out of the way a little bit. Cool. And I decided 20 because it needs to be okay, so this height actually needs to be greater because so let's add in the actual size of the wood for reference. And we'll make these what are known as construction lines, so they won't actually count towards creating this sketch, but they'll help us get an idea for things. Kind of where everything is relative to each other. So if we come in here and change this to construction line, you'll see that they become dotted. And if we dimension them, so this height is 37.5. And then this height is I don't know what that line was intersecting with, so I deleted it. Okay, so this height here is going to be 19.5. And it sticks out 38.5 millimeters. So this actually, we can see now that this, oh, that does actually fit. The dotted line signifies where the, oh, actually it won't. So the dotted line signifies where the wood will be. And so this gap is way too small here. So we need to change 20 as, whoops. Not actually what we want. We probably want to go, so it needs to be at least the gap of the headphones. So 20 plus 17. Can't change that. Why? Oh no. Failed to solve. Please delete one of the following. I'm so confused. Sometimes dimensions make 0 sense to me. So if we dimension from here, we can just say this gap has to be right here, is between the bottom of the wood, and so the headphones can slide right into this little area. I wonder if there's a way to hide dimensions so everyone can look at this a little more clearly. Okay, so this is from, all right, this article is from 2019, so this is a bit more recent than the one I just looked at from 2013. No way to hide dimensions. Okay, well. Okay, so let's see. Next thought is this distance between these two lines. No, it's not quite what I wanted to measure. I wanted to see the distance. It's just showing the distance, but that's a weird. Can I preview these? No. Okay. If I recall, each of these little squares is actually 1 millimeter. It's half a millimeter. Okay. No. Let's see. Each of these squares is a full millimeter, which means that's roughly 1, 2, 3 millimeters high. Which is pretty shallow. I want to make sure I don't accidentally knock these off. So where do we specify this height here? No. Right. I think these just deleted something. Don't know what I deleted. These are equal. These. Is it this? Yeah, it's this one right here. Nope. Sort of. I'm so confused. Okay, that's letting us change that. So maybe 28 is not the dimension we want to be setting here. Okay. Cool. What's an acceptable range? I feel like 10 millimeters would be good. And that was me totally eyeballing with my calipers. Cool. All right. Nope, things can still move around. All right, I guess we're still editing this sketch. Did I accidentally delete your thickness? I did, okay. And what can change about you? Can we constrain these to be like collinear? No. Because I don't really care what the back looks like. We'll just throw a dimension on this for now. Let's give it a whole number. All right, now that's what we got. Okay. So let's extrude this. We'll want to go mid-plane. And going with my phone stand, which is a thickness of 46 millimeters. Oh no, we'll want to do half 46 because half of, so if we do 23, 23 times 20, or 2 is 46. There we go. So if we measure, will this work? It's not really what I want to measure. It's a little bummer that it doesn't do like X, Y, and then like the hypotenuse. But 32 along there. Seems like a little small. wondering, maybe 10, maybe it doesn't need to be 10, maybe it can be 5. I basically just don't want this point sticking out past the edge of the desk. Alright, so what if we inspect distance between here and this point is 32. Maybe we really don't need to arc it up that much. Maybe it really can be 3 millimeters. And then if we come from here to there, well, that's not what I want to measure. From here to there, 32. We'll say that's good enough. Okay, so now we want to add that whole pattern in here. I wonder if there's a way to, I believe there's a way to do screws without actually having to create sketches. Create a hole. I think it's holes. Yes, cool. Okay. So we want a hole that looks like this. The outer Okay, so we're going to do this bit right here. So the outer diameter is 8 millimeters. The inner diameter is 3.5. Let's make that 4, just make it a little bigger. The head of the screw is 2.5 millimeters. I think that's everything we need. We probably want to make this piece here a little bit thicker. So we'll add that in for now. And then we'll go back and edit our original sketch. And this, like 2 millimeters in there. That makes it a little bit, like this screw have a little bit more material to grip onto. And if we go back here and edit our features, so we can add more screws. Can we? I want to add more than one hole. Or I guess I place this and then I do like a pattern of sorts. Let's see. How do you do multiple holes in Fusion 360? Oh, there's a single option for, cool. Oh, from sketch. Okay, so then I need to create a sketch first. So I think if I go back here and roll back, or step back one, nothing is. Oops. Okay, so now I can step back one. Hole's gone, and I can come here and I can sketch. And I believe if I put points on this surface, I'm not going to get too involved in this math first real quick. I just want to see if I can even do this. So that's there, and I go forward, and I edit this feature, and I select multiple. How do I reference the sketch? Okay, I'm going to try creating a new hole. Oh, now I can do it. Interesting. Okay, I'm a little stuck here. All right, let's just cool. Does it maintain my settings? What did I have? 8 millimeters. Yeah. Okay, so it does maintain my settings, which means we can go back and delete this feature because we don't need that anymore. And we can now edit this whole pattern. So I want them. There we go. Okay. So one point to be kind of centered on there, and that's what this red line is. And then this, we'll want to make this vertical. All right, just for reference, let's run a construction line down the center. And now we can do a dimension. Say that, what did we do? We said the whole height of this thing was 46, so this 46 divided by 3? Yeah, cool. And then this is 46 divided by 3. This isn't even connected. We probably want them. I'm totally winging this at this point, so I would not buy too much into these numbers. Cool. So we can now like throw our screws right through there. Nice. Now I'm thinking about how to print this out, and I'm trying to keep that in mind kind of as I was going. So I think it can sit kind of just flat like this, where if this surface down here was the print bed, and then print up, and then we'll have to add some kind of supports for these holes, and that should print just fine. Cool. I'm going to pop this over into Cura. And this is where we will do our preparation for 3D printing. I'm going to turn on the 3D printer. If I can get the USB cable in, just got to rotate it 5 times until it sticks in. There we go. Unfortunately, not today, but soon we will have a new camera so that we can actually monitor the prints. But for now, got to keep this webcam here. All right, so let's open that file we just made. And that's kind of how I said it would sit flat that way on the bed. Most of these settings are standard. I just want to add one thing, which is supports, which it looks like we've already checked this box. I don't know for the record almost any of these settings. I've kind of just learned about the settings that I need when things go wrong. So at this point, I probably know about 15 settings in this entire list of like 200 something settings. So you'll see if we slice that. So basically how this will actually print, and the thing I had in mind was basically it's just going to go layer by layer. Oh, sorry, Hellcat. I'm. Which 3D printer do you have? I have. Or let's see. Do our messages really not showing up? Womp womp. Test test. We're gonna test live. Um, I have the Ender 5. Ender 5 Pro to be specific. You broke it. Well, oh well. I guess that's something I'll have to fix after stream. Yeah, so this is the printer that I own. It can do, what is it, 200 millimeters by 200, 220 by 220 by 300 millimeter prints. It's a lovely little printer. Assembled pretty well after I learned all the calibration and the trouble to calibrate. 3D printing's a bit of a beast. I was kind of happy with it. Mostly happy with it. So the reason I designed this print this way is that if you stick it on its side, it'll basically just add a layer of plastic one at a time, and it'll go up like this. And I try to avoid. We'll show other ways I could have oriented it, the print in a second. And so that one setting I did, which was add supports, basically just adds some material that you can see here. And there's just a little bit of it, and I can basically go in and break that material out. And the whole purpose of this material is to make sure that, like, when it's printing these overhanging layers, as it comes up like this, we don't want all this plastic to fall in because it's all just basically melted liquid plastic when it prints out. So if I had actually taken this and maybe I'd made a poor design choice and I had something like this, as this prints up without supports, all this area in here, when it gets up to here, is just going to fall over because it's just melting plastic, very molten hot plastic, and so it just fall down and you end up with a really bad print. So if we did this way with supports to prevent it from falling down, you'd end up with this chaotic mess that you'd have to break off. Just like a ton of plastic. And if you'll notice, this takes an hour and 36 minutes to print because it has to print all of this cruft in here. So if we instead go back to the way it was oriented before, we slice again, it's 40 minutes less because we've taken into account our design, the end printing process. And it's just these holes that we have to worry about, but otherwise this will print rather nicely. So I think that's it for this session. I think I'll take a quick break from this stream. I'll set up my printer, and then I'll just let the printer run with the webcam going, but kind of in a more passive mode. Yeah, so that is it for this project. Hopefully if things all work out, I'll just screw it on my desk, plop my headphones in it, take a picture, call it a day. If you're curious to see updates on this project, you can, if you look down below the video, you'll find a link to Instagram, which is where I post the final results for all my projects. And I will also link to Thingiverse where you could download this model and edit it yourself. And I will. What else will I do? I will record this and throw it on YouTube as well. And YouTube, I'll link to this initial recording and then all the files and stuff that you need to do this yourself. So, it's the end of my rambling. Thank you for joining me today, especially Hellcat. Thank you for keeping me company in chat. And if there are any last questions before I depart, feel free to throw them in chat. Otherwise, I will save this to file, load up my printer. Can never figure out which URL is going to work. Oh no, is it this? Is it 3? I can't remember. I got a fun little thing called, it's called Octoprint, which is a Raspberry Pi connected to my 3D printer, which lets me, without having to connect wires or anything, send my CAD files directly over the internet to my printer. It's a little finicky though, sometimes. Hopefully this will work and then I can kick off this print and then we can say goodbye. All right, that's going to take a few seconds. While it's going, I just want to throw in a quick plug. If you haven't, check out painlessprototyping.com. I'm doing a week-long series of 3D CAD code and circuits tutorials, kind of similar to what you see here, but in a very compact, very dense format. There's a whole schedule and frequently asked questions. I'll be streaming live here on Twitch, and then I'll also be recording for YouTube. So you can check that out at painlessprototyping.com if you're interested. We're up with Octoprint, so we're going to connect. We are going to upload that file we just created on our desktop. There it is. We're going to hit print, and our printer's heating up. So, that's all for now. Thanks again, and I will catch you all next time. Peace.